Okay, this is an interesting question. This question says, how high does a rocket have to go above the Earth's surface before its weight is half of what it would be on the Earth? Let's draw a picture. This is an interesting one. Here is the Earth, and the question is saying, how high above the surface does this spaceship have to go such that the rocket has to go before its weight. And now remember, what is weight? Weight is force of gravity, such that the weight is, let's write this down. Where is Fg half that on surface? Question mark. Now, by the way, they're asking for, when I say where, they're asking for this distance above the surface, not from the center. Okay? Oops. That's not a very straight line. But that is a radius of the Earth there. Okay. Well, let's write the equation down for force of gravity. Force of gravity is equal to G mm over r squared. And we haven't been given the mass of this rocket. We don't know what little m is. But understand that that's not really important, because no matter what the mass of the rocket is, it's always going to be half of whatever it was, right? More importantly, this question is asking, where is the gravitational field strength going to be half? Because if the gravitational field strength is half, then so will the force of gravity. Because you see, the mass of the rocket's not changing. Obviously, we cannot change the mass of the Earth. That's a constant value. Obviously, also, we cannot change the gravitational constant. Therefore, the only thing we can change is the radius. Okay? Question. What is the gravitational field strength on the Earth? Surface. That's just equal to G, mass of the Earth, divided by the radius of the Earth squared. Now, we all know, by the way, that this equals 9.8, but that's not really important here. What is important is what coefficient do we multiply the radius, which obviously is the only thing we could change, such that we get 1/2. So if I write this equation out again, it's not good if I write 2 here, because if I write 2 times Earth radius, you see the problem now is that I'm squaring it, and then when that comes out, it becomes a 4. So that's a quarter. So the question now becomes is, what factor should I multiply in here? What factor should I multiply the Earth radius by in order to get a 2 outside of these brackets? And I hope you can mathematically recognize that the answer to that is that you're going to have √2 times the Earth radius all squared is going to be, outside the brackets, a 2. Okay? Times the Earth radius squared. Now that is this. And guess what? That is the original gravitational field strength of the Earth at the surface. Therefore, this is 1/2. So how did we have to change the radius in order to get to that value? Well, we had to multiply it by a √2. Okay? So the answer is this distance must be √2 RE. However, that's not what the question is asking. The question is asking, what is the distance from the surface? So therefore, we have to subtract 1 Earth radius. We have to go root 2 RE, subtract 1 RE from that, and that is our answer. Well, fortunately, look how nicely the math works out. We can factor out an RE and simply get root 2 minus 1. And that is our answer. That is the distance above the Earth's surface that this rocket ship would have to be located at in order for the gravitational field strength to be half of what it is at the Earth's surface. Okay? Hope you enjoyed the video.